Today I have a short video, and this is another of the requests we've received, and this is about Fibonacci's. The request asks how to draw Fibonacci from code and then read back the values to use in an expert. So I interpret this as meaning that someone wants to have automated drawing of Fibonacci's on their chart, and then they want to use the levels from that Fibonacci in an expert. This breaks down to several things. Actually, drawing a Fibonacci is easy. The harder part is deciding where the endpoints of the Fibonacci are going to be. So I'm going to show in this video, firstly, a technique for finding the endpoints for a Fibonacci. There are many possible techniques, but I'm just going to show you one that will find high and low peaks. How to draw that Fibonacci on screen. Things you can do with that in terms of manually manipulating the levels. And then techniques for reading the values back from that Fibonacci, but also if you have those endpoints, I'll show you some functions that mean you don't even need to draw the Fibonacci if you're using this in an expert. This code will be for MetaTrader 4 and MetaTrader 5. I'm writing the code as a script, but I'm putting all of the useful functions into a separate file so that you can easily include that file in your experts or indicators. I've already created the files for this tutorial just to save a little time. I'm going to be showing the tutorial as a script, so I have my script files here, the Fibonacci demo MQ4, MQ5 and MQH. We'll get to those soon. But the purpose is that you can call this from, say, an indicator or an expert advisor. So all of the actual useful functions are in this MQH file, Fibonacci.mqh, that I've put in the include orchard shared folder. So that's going to be generally available to experts or indicators if you want to use them. But I'm just using a demo because it's the quick way of showing how the functions in here work. And because this is where most of the work happens, I'm actually going to start with writing the Fibonacci.mqh file. And that's the file I've got open in the editor here, Fibonacci.mqh. And because I'm trying to write this demonstration as a totally automated demo where it can create and draw the Fibonacci for you, then I need some way of finding those beginning and end points. So I've got two small functions here, one that finds a high swing point and one that finds a low swing point. And the purpose of these is to find a point such that with a given look back of bars, that point is the highest point for that many bars behind. It might make more sense if I write the code and show you. So this is just the high peak finder. It takes a symbol, a time frame, a starting position, a number of bars to look back, and there's a double value, which isn't actually an input variable. It is returning the value, which is the high point of the peak that's found. And the find high peak function actually returns an integer, which is the bar number of the high bar that's found. So we just start by initializing this variable high bar to the same as the start, and then I'm using a do loop. I set start to high bar, which obviously on the first iteration of this will be no impact because it's the same. But then I reset high bar by looking for the highest for the given symbol, time frame, searching mode high, which is the high prices, for the number of look back specified bars, beginning with the current start bar. And I keep doing that while the high bar is not equal to the start bar. So if I call this function and it returns a high bar that is to the left of the start bar, then these two values will not be the same. High bar will not be the same as start. Then I'll go back into the beginning of the do loop. I'll move the start bar to the new high bar and do the same thing again. So this will keep executing as long as there is a bar to the left of the found bar that is higher within this number of bars of look back. So typically you might set this to something like 10 or 15 bars look back. You'll begin at bar number 1, which is the bar that's just closed. You'll find the highest bar in that 10 or 15, and then move to that bar and do the same thing again to see if there is another bar to the left. And the reason I do this, if I simply said it's the highest bar for 10 bars, then I could easily be on a downward slope, and the 10th bar is the highest of that 10, but the bar immediately to the left of that is even higher. So that doesn't really make sense as a swing high. So that's why I have this loop that will keep searching until I find a bar such that there is nothing to the left that is higher. And I know I've found that when high bar comes back to the same value as the start bar. And then all I do is pick up the value from that bar, which is the I high symbol time frame high bar. I return high bar, which is the return value of this, but value is this argument that's been passed in by reference. So when you call the function, you also get back a value which tells you what the value of that high bar was. Now that was just for the high peak. I've also got a similar function for the low peak. So the arguments are the same, the structure is almost the same, low bar equals start this time instead of high bar. But now I have to use the iLowest function, searching on mode low, and to get the value back I use the iLow function. So other than that, the structure of this is the same as it was for the find high peak. So I'm going to be using those two functions from my script to find a high and a low bar value, and then I'll simply compare the bar numbers of those two so I know which came first, the high or the low, and that will tell me which direction to draw the Fibonacci. When I come to draw the Fibonacci, I've actually got two different functions. Now this first function has the same arguments except for this leading long chart ID. So I've simply created this function so that you can call draw Fibo for the current chart without having to pass the chart ID in. And all it does then is call draw Fibo, this second function, passing chart number 0, which is the current chart. So now in the draw Fibo function, the first thing I do is set up a result variable that I'll be passing through so that I can return, because this is a Boolean. In my demonstration, I don't actually have much to do with this, but you may find it useful to be able to return a Boolean and know whether the draw Fibo has been successful or not. So I have a Bool result, which I'm initializing to true. And then this int found, there's a function called object find, which will simply look on the given chart, which by default is chart 0, for an object with the given name. And the name is passed in, so this is the name of the Fibonacci object on screen, and the chart ID is typically 0. Object find will return the number of the chart where this is found. So if this returns a negative number, it means that this named object doesn't exist and doesn't exist on the chart ID supplied, and that means that the Fibonacci that I'm trying to draw now hasn't already been drawn. So I'm just searching int found equals object find, and if this is a negative number, which I'll test in a moment, then I know that I've been unsuccessful in finding it, and so I have to create a new Fibonacci. So that if found is less than 0, I need to create the object. And that's a simple object create statement. There's the chart ID and the name that we've already passed in, the type obj_Fibo, subchart number, which is 0 because I'm putting this on the main chart, and then a start and a finish, which is time 1, price 1, and time 2, price 2. And these were passed in as arguments here: date time, time 1, price 1, and time 2, and price 2. Now the way that the Fibonacci object works on screen, time 1 and price 1 are at the 100% level, and time 2 and price 2 are at the 0% level. And that's just something to keep in mind when you're making the call to this function. But then if found is greater than or equal to 0, that means that we've actually found this object on screen. But I'm just being careful here, and I want to make sure that we didn't just find an object that has the same name but is not a Fibonacci object. So there's an object get integer function passing in the chart number. Sorry, I should have had chart ID there. Passing in the chart number, the name. The argument then is obj_prop_type, and that returns a value that says what type that object is. And if that is not an obj_Fibo, then I've chosen in my demonstration to simply return false and not do anything further. You may prefer to simply delete that object if it's found. In that case, you might want to move this test further up in the code so that you can delete the object, set found to a negative value, and then you'll go through here and recreate the object. But I've chosen here to say that if I found the object and it's not already a Fibonacci object, then you probably don't want to delete it. And so I'm simply returning a false there. Now once I'm past that point, all I need to do is set the new values for the Fibo object, because it already exists on the chart. Possibly the time or the price points have moved. And the reason that I'm not simply deleting the object and recreating it each time, if the object exists on screen and you make some changes to that Fibo object, perhaps changing the colors or even moving the levels around, so you might want to have some non-standard levels, you can do that to the object that's on screen, and by moving it, all your changes will be carried across with the move. So if you created a 12.5% level and I move this to a new location on screen, the Fibonacci will extend or contract depending on the new values of price 1 and price 2, but that 12.5% level will remain. If I deleted the object and recreated it, you would lose that 12.5% level that you created. So that's why I'm going to the trouble here to test if the object exists and to move it if it does exist or create it if it doesn't. And to move it, I'm just setting some of the properties. So object set integer is used to change the times, and the arguments to that are the chart ID and the name, objprop underscore time, and then the sub argument, I'm changing the 0 time or the 1 time. Now I know the arguments here are time 1 and time 2, but they relate to sub elements 0 and 1. And then the same for the object set double for the price. The argument here is objprop underscore price. Now these functions, object set integer and object set double, return booleans. Remember I set this bool result equals true. In each of these calls I'm then saying result ampersand equals. So as soon as one of these fails, or if one of these fails, result will be set to false, and it will stay false by using this syntax. And that way at the end of the function I can simply return result, and that will tell me whether all of these have been successful or one of them has failed. And so by just setting the objprop time and objprop price, sub values 0 and 1, to the new time 1, time 2, price 1 and price 2, it will move that Fibonacci object on screen. Those are the basics for drawing a Fibonacci object on screen. There are a number of other properties you can set. You can search the help to see what they are. I'll put some comments in here to show some of the other calls you can make, but remember that I've only passed in the values for this time 1 and price 1 and time 2 and price 2. So if you want to set any of the other values, you're either going to be hard coding the arguments here, or you'll pass more arguments into this function. So those comments will be there in the code that you can download. And then just to finish off this function, I'm calling this chart redraw just to give an opportunity for the chart to redraw the new Fibonacci object. But when I get to actually writing the code for the script, you'll see that I've had to insert an extra delay for MetaTrader 4 because there does seem to be a slight timing issue if I'm trying to access the object as soon as it's been created. Doesn't seem to be a problem I'm finding in MetaTrader 5, but you'll just see a small delay that I've introduced outside this function. So that takes care of the functions for creating a Fibonacci on screen and moving it around. Now I'm down to functions that I'm going to be using to interrogate that object on screen and get values back from it. So the two first things I want to get are the endpoints for the Fibonacci. So the first function, get Fibo start. And as I say here in the comment, gets the first Fibo point, which is the 100% level. I mentioned that earlier. And the end Fibo point here in the second function, that's the 0% level. And those correspond to these time 1, time 2, price 1 and price 2 points. So the arguments to this, it returns a Boolean to simply say that I was successful in getting the values back. I'm passing in the chart ID and the name, and then I want to return the time and the price, so I'm also passing these two variables by reference, time and price, and so they will be populated with the time and the price of those Fibo points. And it calls this other function, get Fibo point, which I'm about to write. If I scroll this a little bit further, And I'm doing that because I've written the same function for both the Fibo start and the Fibo end, and the only difference in the arguments to this get Fibo point are this, which simply tells me whether I want the 0 set of values or the first set of sub values for the time and the price. And I've done that because the code in here is the same except for this value, and I don't want to duplicate code if I can avoid it. And now that get Fibo point function so the argument's obviously chart ID, name, that sub value that we want to get, and then the by reference arguments for time and price. And this returns a Boolean, which is then returned by the get Fibo end or the get Fibo start functions. The first thing I want to do though is test that this object actually exists. So I have this int found equals object find to chart ID common name, and if found is less than 0 then return false, so that Fibonacci object does not exist. You could add an extra test here as well, so that after if found is less than 0 you also check to see that it is a Fibonacci object, and you've seen the code above for that, so you can just copy that into here if you want to add that extra check. But then time is simply object get integer for the chart ID, name, obj_prop underscore time, and point number, the sub value, and I'm actually casting that to a date time just to avoid any compiler warnings. And the price then is the same thing, but object get double, and the argument here is obj_prop underscore price, and then I just return true. And now I have a function that is not strictly anything to do with Fibonacci. If you are using this from an expert advisor, say, and you're actually calculating those high and low points, there's not much reason to actually create a Fibonacci object for your expert advisor. You can simply calculate the ratio distance between those 2 points. And so I have this function called get Fibo level by ratio, and you can simply pass in 0.1 and 0.2, and they are still the 100% level and the 0% level, and then the ratio, which might be 0.382 or any other ratio you like, and it will give you the value that would be at that level in a Fibonacci without actually using a Fibonacci level. And it does that with a fairly simple calculation. Beginning at value 2, it adds then the difference between those two values multiplied by the ratio. And now I have another function where, in case you do have a Fibonacci on screen and you want to use that, perhaps you're manually drawing the Fibonacci and relying on that to set the levels for your expert, but you want to use a non-standard level for some reason. You may want to call a get by ratio value, but with a manually drawn Fibonacci on screen. And this just wraps up calls to some other functions. So if you're passing in the chart ID and the name, then that's looking for that particular Fibonacci on screen, and then a ratio, which is the same ratio that you would pass to this other get Fibo level by ratio. I'm declaring 3 variables, time, value 1 and value 2, only because I need this time to be able to pass into the get Fibo start and the get Fibo end functions. I'm not actually using the time for anything else, but it's one of the arguments here. All I really want to get back are value 1 and value 2. So I call the get Fibo start value 2, and I call the get Fibo end value 1. And if either of those fails, because remember they are Booleans, then I just return 0 from this function. If they've been successful, then I can call the earlier get Fibo level by ratio, and I just pass value 2, value 1 and ratio, and that gives me the point between those two levels for a manually drawn Fibonacci. So this would let you have, say, an expert advisor where you've drawn your own Fibonacci on screen and the EA checks that Fibo to see if levels have been crossed. Now the next thing to go with that might be if you want to interrogate a Fibonacci on screen and get one of the standard levels from that. So we know that the standard levels are at places like 38.2%, but you may have moved those levels around. So this function lets you specify a level by number, remembering that the 0% is level 0, So counting from that, this will find any of the levels in your Fibonacci and give back the value of that level. Get Fibo level, chart ID and name as usual, and then the level number that you want. The usual function here, int found equals object find, and if not found, then I'm printing a warning message, not found, name, and return 0. And again here, I haven't bothered to check that the object is a Fibonacci object. You can add that code in. You can't specify an invalid level. If you specified something like a negative value, then I didn't bother to check for those. I'm assuming that you're not going to be calling this with negative values. But I need to make sure that the level number that you pass in is a level on that Fibonacci. They don't go forever. The levels are defined inside the Fibonacci object. You can create more, but I want to make sure that you don't ask for a level number that is outside the available range. And I can tell how many levels there are with object get integer and objprop underscore levels as the argument. So if the level you've asked for is greater than or equal to that, then I just print a message, it's an invalid level, and return 0. Then I'm calculating a ratio, and that's with the object get double, chart ID name, and objprop underscore level value, and the level number. So this function doesn't return the price at that level of the Fibonacci, it returns the percentage value of that level. So then I simply call again this get Fibo level by ratio, chart ID, name, and ratio, and that takes care of the rest for me. So that's the end of all of my Fibonacci functions. Now I'm going to write the script to demonstrate this. So here in the Fibonacci demo MQ4, I've already written all of the code for the MQ4 and for the MQ5, and you'll see that both of them include Fibonacci demo. And I've done that, as I very often do, so that I can write one set of code. I don't want to duplicate the code in the MQ4 and the MQ5. All of the code is in the Fibonacci demo, and it's common to MQ4 and MQ5. The only difference between these two files is that I have this property strict in MQ4. Now, in the Fibonacci demo, where all the code will happen, I have one input, which is the look back, and remember I use that look back to find the high and low peaks. And I'm including orchard shared Fibonacci, which is the Fibonacci file we've just been looking at. This is a script, so I'm starting with just the onStart function. I'm setting up a variable with the name of the Fibo, so I don't have to keep typing this name everywhere. And I'm just calling this one for the example, my Fibo. First thing I want to do is find the peaks. So I'm declaring the variables for high value and for low value. Int high bar equals then the find high peak, and we've seen symbol, period. Let me scroll this across. Beginning at bar number 1, so that's the start. For that look back, forming the inputs and returning that high value, which is this double value here, and then the same for the low. So I'm just looking for those to demonstrate those two functions, and that will tell me where the high peak is found and where the low peak is found. So the next thing I have to do is determine which of those is the beginning point and the end point. So this simply tells me that I've got a high value and a low value. I'm going to have to compare this high bar and low bar to know which is the beginning and end point. And that's a simple test. If high bar is greater than low bar, then I know the high bar is the first one found because the numbers count upwards to the left, time 1 and value 1, and the low values for time 2 and value 2. And then in the else, I've just reversed that. The low values go into time 1 and the high values go into time 2. After that, I can just call the draw Fibo function. Simple name, time 1, value 1, time 2, value 2. I've used the shorter form function here where I'm not specifying the chart ID, but you can specify a chart ID if you want to draw on something other than the current default chart. And then here, as I said, I found in my testing on MetaTrader 4, because this runs straight onto some statements that I'm about to write, I found that sometimes the object would not have been fully created and I was getting no levels back. So I've just added in a sleep 100 here. That's probably not necessary in your own code unless you're using that Fibonacci immediately after drawing it. Now at the third step, I want to get the values from those levels on that Fibonacci. And I've just chosen levels 2 and 6. So I'm using this statement print format. Level 2 equals %F, level 6 equals %F. And the arguments, which I'll just wrap around so you can see them better. I'm then just calling get Fibo level 0, name, level number 2, and level number 6. So those values from the get Fibo level function will go into these placeholder arguments in the print format. And the last step in the demonstration is to show the use of that function where I don't even need a Fibonacci on screen. Now I know that by the time I get to this, I will have the object on screen. So what I'll do for the demonstration later, I'll actually comment out this draw Fibo so that it doesn't appear when I'm showing how this operates. But I'll just leave it here for now. And this simply says without drawing an object, level 38.2 equals and level 161.8 equals. And then I do the get values by ratio, value 1, value 2, which I've already captured up here, value 2 and value 1. And I've set those as the beginning and end points for the Fibonacci levels. And I call the get Fibonacci level by ratio for 0.382 and 1.618. So that'll give the values back. I'll run this the first time and you should see that the results in both this part 3 print statement and the part 4 print statement are the same. And then I'll make a change to this code and actually comment out this draw Fibo so that we don't have that object on screen. And then you'll see that we still get a value in this part 4 just by getting the level by ratio. So now let's compile this and then I'll flip over to MetaTrader 4 in this case because that's where I've written this code and we'll see that run. Now this is the MetaTrader 4 terminal open, Euro USD 1 hour. I've blown up the bars a little bit so they're easy to see. Here on the left I have the Fibonacci demo. I'm just going to drag that onto the screen. Inputs, I'm going to leave this as look back of 10 to begin with, and OK. So it's drawn a Fibonacci there. I'll just bring that up a little. So high peak was found at bar 19 and low peak was found at bar 1. I only specified a look back of 10, so given that this is bar number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is bar 10, which was clearly a high bar, but within 10 bars of that, it has found bar 19, which is higher. So that's where I said it repeats that loop until it can't find a higher bar within that 10 bars. So bar 10 was high, but not quite high enough. So bar 19 is the high bar, and the low bar, it says here, is at number 1. Now I'm not counting 0. Remember I started at bar 1. So starting at bar 1, and that is the lowest bar for 10 bars. The next thing we have here, level 2 is at 1.084256 and level 6 is at 1.088904. So level 2, remember this 0 is level 0, 1 and 2. So that puts me here on the 38.2 line, and if I can keep the cursor steady enough, 1.08425, and I'm going to have to just shrink this a little bit to get to number 6. That's 0, 1, 2, 3, 4, 5, 6. If I can keep that steady, 1.0889. So that matches up with these values here. And then we went on to number 4, which says without drawing an object. It doesn't use the object, and it has the same values that I had for example number 3 where it actually looked at the object on screen. But to show that this isn't using the Fibonacci object on screen, I'm going to go back, as I said, here in the Fibonacci demo. If I comment out this line where it draws the Fibonacci, go back, compile again, go to the object list, delete that Fibonacci. I'll clear these logs, run the same thing again, still at peak finder look back 10. And now we can see high peak is still at 19, low is at number 1. Didn't find the MyFibo object, which means that level 2 came back at 0 and level 6 came back at 0 when it was looking for the object. But without drawing an object, I still have the same values that I had before. So, as I said, if this is an expert and you're using those peaks to find where your Fibonacci's would begin and end, you don't necessarily have to draw the Fibonacci on screen. You can use this kind of function just to get those level numbers. But perhaps your object is relying on your manual intervention to set up a Fibonacci on screen. In that case, you would use the values from this example number 3, where I'm calling and finding the Fibonacci object and getting the levels from that. And now, just to show that this works for MetaTrader 5, I've got the MetaTrader 5 editor open. Same file, I've taken out the comment on that draw Fibo line. I'll go here and compile. And now on the MetaTrader 5 screen, Fibonacci demo, drag that in, inputs, value 10. Okay, now I'm running this at a slightly different time, so you can see the Fibonacci's been drawn differently. I have different values here. The high peak now is at bar number 1, and the low peak is at bar number 4. Level 2, 1.087285. 6 at 1.077495, and without drawing the object, I get the same values for the 38.2% and the 161.8%. So it works for both MetaTrader 4 and 5. You'll notice though for MetaTrader 5 here, the Fibonacci lines end. There is a property and object set integer. You can set objprop_ray right, and then these will extend all the way to the right hand side of the screen. So I hope this has been useful to you. If it has, please click the like button. And if you'd like to see more of our videos, click subscribe and click the bell icon to be notified when we release our next video. Thank you for watching.